Hey folks, it's Pat here. Got a chapter 10 question that I want to cover real quick. Got a request on this one, and that's determining the null and alternative hypotheses in hypothesis testing. So you're going to do a lot of hypothesis testing from this point on. Every chapter is going to contain some of this, and it starts with a very simple premise, which of course they're going to test you on here. And that's whenever you make a claim, you have to build what are known as your hypothesis statements, okay? So you're testing a hypothesis, all right? And then we use math, okay, to actually determine whether or not we can actually, support that claim, all right? And so hypothesis testing, the way that it works is you're going to put up two statements. The first one, this is going to go in here, and this H0 stands for your null hypothesis. Sometimes you see it as H0 or H0 or HN. I think all the things in ALEKS use H0, so that's your null hypothesis. This other one is your alternate hypothesis, H1, okay? Sometimes you see it as HA, okay? Your alternate hypothesis is your claim, all right? So whatever you're claiming, all right, that's your alternate hypothesis. So I find it's always easier when doing these problems to do the alternate hypothesis first, and then the null hypothesis just includes everything else, okay? And so, for example, on this one, toy manufacturer claims that the mean time that its top-selling toy captures the children's attention is at least 35 minutes. Suppose that we doubt this claim and we carry out a hypothesis test to refute it. So this one's got a little twist to it because they're making a claim, this toy manufacturer, but we don't believe it. So this is actually our alternate hypothesis here, since we don't believe them, okay? And so our pi hypothesis in this one is like, no, your mean time, and this is the symbol for mean, mu, right here, we don't think it's at least 35 minutes. We think it's less than 35 minutes, so less than 35. And so now your alternate or your null hypothesis is just covering all your bases, so it's everything else. We use greater than sign here, and so this one is less than, or no, we use less than, so yeah, they're going to use greater than or equal to, okay? So there we go, check that. And ta-da, we got that one. All right, let's try another one. So here we go. You're going to have to use a lot of these different symbols, so you need to know what they are. So mu is mean, x bar is mean, but I don't think they use, this is sample mean, this is population mean. I don't think they use that one in this. P is proportion, sigma right here is standard deviation, and sigma squared is variance. Okay, maybe we'll get a variance one here. So cholesterol levels of adult males are approximately normally distributed with a mean of 225, listed variance. Okay, we got a variance one of 529. Some researchers claim that the variance of cholesterol levels in adult males is less than 5.29. Suppose we want to carry out a hypothesis test to see if it is actually less than 5.29. So this is our claim right here. Okay, we want to carry out a hypothesis test, and so we're going to do variance. So start with your alternate. Sigma squared is variance, and then one arrow key over. And so we think that it's less than 529. Okay. Now, of course, our null hypothesis has to include everything else, so it's exactly the same, sigma squared. But rather than using this greater or less than sign here, we think, or our null hypothesis would be true if it was greater than or equal to 529. See how you cover your bases here? So you got everything in there, and then let's go ahead and check that. And so there's a couple different types that you can get. Let's just try one more here, just because there are a lot of different combinations in here. And so the more I can show you, I think the better it will be. So a decade-old study found that the proportion of high school seniors who felt that getting rich was an important personal goal was 70%. Suppose that we have reason to believe this proportion has changed, and we want to carry out a hypothesis test. To see if it's supported. Okay, cool. We got one of the ones that's a little bit interesting here. So because hypothesis testing comes in two flavors, you can have a one-tail test or a two-tail test. A one-tail test is where you're only going to look at one side of the distribution because, hey, we think it's greater than, so if we can't establish that, then obviously we're not right. Or sometimes it's like, hey, we think it's less than, so if we can't establish that, we're also not right. Okay, but sometimes we need to test both sides because we're not sure. We just think it's different, okay? That's a two-tailed test, and so that's what we're going to do right here, okay? So, and these are much, much easier to do, all right? So once you determine that it's a two-tailed test, because rather than saying greater than or less than, all it'll say is difference or different, and so, or has changed or something like that, it doesn't give us a direction. Okay, so this is a two-tailed test. And so this one is with proportion. Proportion is P, and so we think that it's not the same as it was before, which was 0.70. Makes sense? So it's no longer .70, and then of course we would be wrong, and our null hypothesis would be, yep, it still is .70. Let's give that a check. And there we go. So actually we got lucky there, because there are a lot of different ways that they can throw these at you. But as long as you take a moment to kind of pick out all the pieces here, start with your alternate hypothesis, establish the claim, and then your null hypothesis covers all the other bases, so it's everything else. So if your alternate is greater than, your null is less than or equal to. If your alternate is no more than, then of course, you know, your null hypothesis would be greater than. Okay, so it just depends, and you have to kind of pick through the language on this one. And then finally, watch out for this last one where it's two-tailed, where it's just difference, and that one's going to be does not equal or equals. Okay, so I hope that helps. I hope that kind of clears some of this stuff up. You're going to get really good at this as you go through the next couple chapters, and so you'll look back on this one and say, that was a piece of cake. But anyway, I hope that helps. We'll see you again soon.